Hello everyone and welcome to this webinar on the role of electrical vehicles in Asia Pacific cities. My name is Michael Jacobson and I'm the Executive Director of APUEA. I will moderate this webinar today and I have Ms. Carrie Chen beside me to help with the technical issues of the webinar. So this webinar is hosted by APUEA and ABB jointly, and we have the pleasure to have representatives from C40 cities and REN 21 with us today. The webinar is marking the World EV Day as of today, the 9th of September, and we have a quite interesting program in front of us. We will hear from Mr. Peter Lumberg from APUEA on how to meet the increasing electricity demand from electrical vehicles. We will hear from Kumail Rashid from ABB about the future EV technologies. We will hear from Anna Paris from C40 Cities about the development of sustainable mobilities in cities. And we will hear from Leah Ranalder from REN 21 on how to link renewable energies with electrical vehicles. Finally, we will have a Q&A session where you are welcome to write questions in the chat field named Q&A, and we will bring them up in the end of the session. Before I hand over to the first speaker, I would like to give the virtual floor to Mr. Sami Raitakoski from ABB, who will provide his opening remarks.
Okay, thank you, and hello everyone. Thank you, first of all, joining us for this important webinar today to discuss about the critical role electric vehicles and sustainable transport play in our region. My name is Sami Raitakoski and I lead ABB's electrification business here in Asia Pacific. ABB is a pioneering technology leader and we operate more than in 100 countries with around 110,000 employees serving customers in industries, utilities, transport, and infrastructure. Due to the global growth of a smart, sustainable transportation, it is also one of ABB's main focus areas, and we put a lot of efforts to develop sustainable electric vehicle infrastructures with our partners. In our Asia Pacific region, several countries are already experiencing significant growth in EV market. So actually, maybe the best way to demonstrate the speed in this market is to use one of the countries like Singapore as example. So in last few years, we have had projects here in Singapore where multiple end users, partners, organizations, including ABB, have been involved and are leading the way in faster EV infrastructure adoption. So if I start from the example, so here in Singapore, of course, one critical is a fast charging network with the depot chargers and opportunity chargers to support the adaptation in public transportation segment. Then we have also seen in the country collaboration where the bus OEMs like Volvo, together with NTU LTA, work together to develop the fully electric 12 meters autonomous bus to support the future technologies and making sure that this autonomous transportation is also coming more closer to reality in Asia and also in Singapore. We have also seen the areas where electric AGVs, automatic guided vehicles to move the containers in port of PSA. This is coming to the States. We have also seen the very fast countrywide DC fast charging network covering from the gas stations, car OEM showrooms to the taxi depots to support the overall infrastructure development in the country. And of course, it's also important to say that there's also multiple different home charging solutions that Singaporeans have been deploying, and this is of course to support the private EV users. So I use Singapore as example because I'm now based here, but of course we see the similar projects also in other countries in the region, and we need to also remember that there is significant car manufacturing in the region. So we see a lot of people and organizations involved. So it's very obvious that EV infrastructure need is growing day by day. But there is still a long way to go. But fortunately, we are seeing continued advancement in e-mobility in Asia Pacific under the government endorsed projects, but also the government-led strategies. At ABB, we are very proud to be supporting this trend and help accelerate e-mobility adaptation in our region. So I hope that you will enjoy this important webinar, ask questions, and I also want to thank all of you for taking the time to join this. Thank you.
Thank you very much, Sami, for your introduction to ABB and your perspectives on the EV market. It's indeed an interesting development in the sector. I would like to also to say that I'm looking forward to some myth busting here today. Obviously, we hear often about the opportunities, but there are also some skepticism and challenges to overcome. So I'm really looking forward to these sessions today and the speeches to present really about the front end of technologies and solutions and how to meet these challenges. So with that said, I would like to introduce Mr. Peter Lumberg, the Head of Operations of Asia Pacific Urban Energy Association, who will talk about meeting the increasing electricity demand from electrical vehicles.
Yes. Hello, my name is Peter Lumberg. Let me share my screen. All right. Okay, try again. Okay. Yes, thank you, Michael, for the introduction. And so I'm here to talk about how to meet the increasing electricity demand from electrical vehicles. So a little overview of my presentation includes the urbanization trends. I'm going to talk about energy consumption in cities, and I'm going to talk about other trends in the energy sector. Then I plan to introduce multi-energy systems, including district energy, distributed energy, and smart grids, and how this system can help to integrate more electrical vehicles. So in the beginning of the 20th century, there were about 50% of the world's population lived in cities, and by 1950, this figure has risen to 30%. And today, 58% of the global population lives in cities. And this percentage is expected to reach 68% at 50. So this rapid urbanization growth have led to megacities, which are urban agglomeration with populations with more than 10 million inhabitants. Today, there are 33 megacities globally, and 17 of them are in Asia Pacific. And by 2030, this number is expected to be 43 globally, and 25 of these cities will be in Asia Pacific. Energy consumption in cities. So cities occupy only 2% of the world's landmass, but they consume over 2/3 of the world's energy, and they account for more than 70% of the global CO2 emission. So really, if we have to do anything about global CO2 emissions and energy consumption, we really have to focus on cities. But cities, of course, have very different characteristics when it comes to the energy consumption. And that's why it requires different focus to work on. And here I'm showing 4 examples of cities in Asia Pacific, which have different characteristics energy consumption. For example, in Hong Kong, the commercial sector is the largest consumer of energy. In Bangkok is the transportation sector by far, 74%. In Tokyo is also the commercial sector, and in Osaka it is the industrial sector that is the largest energy consuming sector. Some trends and developments in the energy sector. So talking about urbanization, the current urbanization trend has resulted in increased energy demand and also increased energy density, and local pollution. This leads to challenge as stressed electricity grids, but also opportunities to use decentralized solutions and thereby reduce stress on electricity grids. There's also opportunities for cross-sectoral integrations of, for example, the transportation sector, the building sector, utilities, sewage, and also energy symbiosis, prosumers, consumers, and waste heat recovery, for example. The digitalization trend involves improved monitoring, control and optimization, forecasting of both weather and user behavior, and also consumer engagement. Looking at some developing trends in the energy sector includes electrification of the transportation sector, which supports decarbonization through introducing more renewable energy. The decarbonization of electricity, heating, and cooling, and also decentralization to develop local solutions and utilize local resources. And finally, the system integration, for example, utilizing thermal networks like heating and cooling systems as energy storage, but also looking into co-generation, the production of electricity together with heating and cooling, or both. Looking into the global electric car stock. So these are numbers from IEA. So in 2019, there were 2.1 million sales of EVs in the world, and that's an increase of 40%. So now there are 7.2 million electric cars in the world, which is only 1% of the global car stock. So we can see really what challenge we have ahead of us in our societies and in our cities when this number is and this growth is going to continue. So looking into what is multi-fuel energy systems. So basically these systems are key to sustainable cities. They normally include or integrate multi-fuel energy systems that incorporate energy efficiency, renewable energy, and also demand-side management. And the advantage of these systems that they have high adaptability to change in fuel availability. They're more effective to utilize low-value surplus energy and renewable energy. They can allow for flexible integration of intermittent renewable energy, for example, through energy storage. They also can help to reduce peak loads. Some examples then of these multi-energy systems includes district energy, district heating and district cooling, distributed energy, cogeneration and trigeneration, which is producing electricity, heating and cooling at the same time. Also combined heating and cooling in some areas in the world, some cities, and also smart grids. Looking into smart grids, they offer increased grid flexibility, which allows integration of more renewable energy without necessarily using energy storage. It also allows the bi-directional energy flow from, for example, solar, PVs, batteries. So it's a new market platform where actually electricity becomes a commodity, where you can sell your power from solar PVs or from maybe from your electric car back to the grid. It leads to increased efficiency in the grid and the efficient use of energy when using demand-side management, basically connecting together production and consumption of energy and really enhancing the communication between the consumer and the producer. It also leads to improved load balancing. So for electric vehicles, it's really important with smart grids, and it allows for smart charging and optimized charging, for example, the user managed charging. But it's very important to control when we charge our electrical vehicles. So we really charge our cars off peak, reduce peak loads. So there are different ways of doing that. You can use user managed charging, which is basically using a price incentive to shift the charging time to make people charge a car off peak. It also allows for the possibility to discharge electricity to the grid from your car. That's called vehicle to grid. And that can also help balance the grid, for example. So here you can see an example then of a curve when you can compare standard charging, which is the purple line, with smart charging, the green line here. You can really reduce peak loads and reduce a large capacity of electricity grid, both on the production side, but also the distribution side. District energy, and in this case, I'm sharing information about district cooling. District cooling is basically when you have a centralized production of chilled water, which is then distributed to a piping network to several buildings, customers. These systems have several advantages where conventional cooling systems. They are up to 50% more efficient, use up to 50% less energy than conventional cooling systems, but they also allow for the installation of less capacity to produce this chilled water, 15% actually, approximately. Utilizing energy storage, it also helps to shift to reduce peak loads in the electricity grid, as you can produce chilled water off peak and use that water for later when you have high peak in the electricity grid. It also allows to integrate intermittent renewable energy as renewable energy. When you have excess renewable electricity in the grid available, you can produce chilled water to store in the thermal energy storage to use for later. Distributed energy offers also several benefits. It's very efficient when you can utilize up to more than 80% of the fuel input that is converted to useful energy for electricity, heat, cooling. It also leads to decentralized energy production, which means that you have local power production, which leads to reduced stress on power grids. And also having the system connected to very efficient cooling and heating system, that in itself will also lead to high reduction of energy demand in the area and optimization of energy use in that area. So these are also important. Now I'm going to explain how this system can help to integrate electrical vehicles, basically. And so looking at smart grids, basically they play a very vital role to introduce EVs by balancing the grid and enable reduction of peak loads. Also open up for new market solutions and communications between consumer and the production of electricity. District cooling has increased energy efficiency. That leads to reduced energy demand and also reduced installed capacity. And thermal energy storage can reduce peak loads and integrate more renewable energy, which leads to increased available grid capacity and reduction of peak loads. So there's more capacity available for EVs cities when you utilize district cooling. And looking into this distributed energy, it leads to decentralized power production. Is highly efficient. Also enables, in connection with highly efficient heating and cooling systems, reduces energy demand in the area, as well as reduce installed capacity compared to if you have conventional cooling and heating systems. So that also leads to increased available grid capacity that can be utilized for electrical vehicles. So when looking into meeting the demand for electrical vehicles globally and in Asia Pacific, you really have to look at multi-energy systems and how the best way to meet the demand and optimize really the energy infrastructure in cities. Okay, thank you very much. That's all for me.
Thank you very much.
The next slide. Okay, thank you very much.
Thank you, Peter. Thanks for this introduction and a larger perspective to urban energy and the importance of electrical vehicles to transform the transport sector, not least in Bangkok, as presented there in the presentation. Also interesting with the advantages of smart electric, but also thermal grids, integrated energy systems and multi-energy systems to integrate electrical vehicles. So with that, I would like to move on to the next presenter, Kumail Rashid, who will present future of EV technologies. So the floor is yours, Kumail.
Great, thank you for that. All right, so let me just confirm that everyone can see my screen. All right, I think that should be okay. Yep, okay, I see some nods, which is good. Okay, well, hello everybody. Okay, right, now, given today is World EV Day, I thought I would be sharing a little bit in terms of the technology that we have to deploy and enable, facilitate e-mobility uptake, specifically what we're doing here in Asia Pacific. Now, rather than showing you a slide deck, which is typical in terms of the technology, I figured let's just dive straight into what we have here. And so in front of you, you can see an ABB Smart Societies map. This is our technology that we deploy in urban and industrial environments. And I would like to focus specifically on the e-mobility side of things. Here is our smart city. So we talk about smart buildings, e-mobility, different industries like water, energy, and how we go in. So what I'd like to do is let's dive into the e-mobility side of things. Now, as you can see, we are looking at deploying technology that not only enables EV charging, but essentially we're looking at a scenario where we're providing end-to-end solutions. So this is all the way from what your car needs to all the way to the connection from the grid side and further as well. And how do we enable that? What is the relevance? I'm glad it was mentioned. Let's do some myth busting. So I'll show you a little bit about some technology to enable this as well. Now, in general, what we have here is a scenario where for e-mobility, we can categorize broadly into two different sections. We have destination charging, when you have a little bit more time, your vehicles are packed, maybe overnight, maybe while you're in the office, and you can afford a slower level of charging. It suits your needs, and as long as you have the sufficient charge to move on to your next destination, then it's sufficient. We also have en route charging. So let me go into a little bit in terms of what both are. Now here we can dive into a scenario which is for our apartments and office destination charging. It's also relevant for residential charging. So here you can see we have a number of vehicles parked outside of an office building, for example, and we have various solutions for that. So what are the exact EV charging infrastructure that you can do, and what is actually being deployed right now? So in general, for this destination charging, we have two major solutions, right? One is your standard AC solution, which would typically charge your vehicles anywhere between, or depending on the vehicle, 8 to 10 hours, 12 hours overnight, maybe 6 hours while you're at work, depending on the capability. And this is sufficient. How this interacts with the grid, how much power is being consumed from the site, is all relevant. Now, when we go into requirements of a little bit faster charging, we start looking into things like, okay, well, we need a little bit more. So here you can see a picture of a DC wall box. This is our newly launched product that we've already started deploying here in the region as well. And this one is a 24 DC wall box, which will typically charge your vehicle in about 2 to 4 hours, right? So this will be ideal for a scenario where someone has come in, they've come in for a work meeting, they're staying for a few hours, they'd like to top up their vehicle, perfect. What's also important is that we are now combining this with a complete scenario of apps for user interface and being able to control. So you imagine being at a cafe, for example, you're able to look into your app, see how much your vehicle is charged altogether. You might be at home. You might like to schedule the timings to start at off-peak rates, for example. Maybe you get cheaper electricity after midnight. So that's all controllable via an app, and you'll be able to control with that. Now, this is just a little bit of a taste in terms of the destination charging. If I go into something more in terms of, let's say, the fast charging side of things, the en route charging for vehicles, what we're really looking at is solutions where we call it opportunistic charging, where you have a small opportunity to be able to charge, you're on your way to somewhere, and you're looking at being there for the shortest amount of time possible. You're really looking to get to your next destination. So here you see a scenario where we have coupled the charging infrastructure as well as what the city requires in terms of grid connection. Sometimes you'll have available power. Sometimes you'll have a constraint of power. And I'll speak a little bit more about that very shortly. But in general, when we talk about the EV infrastructure itself, you start to see this very, very common. We're looking at the standard, let's say the go-to charging product is a 50 kilowatt fast charger, which you can see here now. This would typically charge your vehicle, depending on the battery capacity, around 30 to 45 minutes. So still not extremely convenient, but perfect for those type of scenarios where you're looking at, okay, maybe I'm heading into a fast food restaurant. Maybe I'm quickly going into a supermarket or a shopping mall, going in there for half an hour, getting my top up, and off I go, right? Or we're looking into coupling this with roadside type of charging as well, which is similar to what you can see here. And when we get into this specific EV charging sites, we start to look at higher power charging. And now these are also being deployed in the region. We are talking about 350 kilowatt type of charging here. And if your car is capable, you really can charge your vehicle in about 5 to 8 minutes, right? You get about 200 kilometers worth of range, and that's more than sufficient to help you onto your journey. So you come in there, you charge up, and off you go to your next destination. Now, obviously, when we talk about what is happening on the grid connection side, because it's not so easy to put these chargers all over the place. They require a lot of power, and it just so happens that we have a solution for that as well. What we are starting to deploy and looking around here in the region as well is these prefabricated grid-connected type of solutions. So it depends on the requirement. Is the site specifically built for an EV charging requirement where you have multiple chargers at a destination and you need to provide sufficient power? In which case, we're able to provide you scenarios where you can have a look at this. So these are completely designed, ready to go, almost out of the box. You design it and you can drop it off on site. So all you have to do is connect the grid up to it. It provides sufficient power and be able to connect to the rest of the charging stations. In this picture, you can actually see that the 50 kilowatt units are actually mounted on the skid as well. But what we do is we actually have different scenarios as well. Do you need a little bit of solar on that kind of connection? Do you need to have high power charging incorporated into that as well? So all these flexibilities are possible, and these are solutions really targeted to fit the urban requirements and where you need to be able to put these charging situations and solutions in place. Right. Now, along with this en route charging, so that's definitely on the vehicle side, but specifically when we go to Asia Pacific cities, yep, we are a little bit behind in terms of what Europe and the Americas have been doing, but I think that's also given us an advantage, right? We've been able to see what is the technology and what is the exact use case for what we're able to do right now. I believe we have a lot more opportunities, given that we're still waiting for price parity on the vehicles, the cars themselves, and it will still take a little bit more time in terms of the uptake. We really have an opportunity to look at things like bus charging. So here, I won't go into the depot side of things, but I'll show you what it's like on the en route charging for buses. And here you'll be able to see exactly that. So in this type of scenario in an urban environment, we have buses which can typically stop at these pantograph-based chargers anywhere between 2 to 4 minutes where passengers are alighting or getting on board the bus. And this will really charge the bus sufficient energy to drive another 30 or 40 kilometers, right? Depending on the routing, depending on the fleet schedules, depending on the overall structure and the map of the route. So what really is important here is to see that this is also facilitating a need. It's available today, right? We've already deployed this technology here in Singapore for the Land Transport Authority, and this is something that really fits a need in being able to facilitate public transport. And this is really key to where we can start getting into good emissions-free transportation. So here you can see, if I click on it, we have a modular type of system as well in this scenario. So depending on what the fleet requires, what the operator requires, we're able to add in multiple cabinets and give you charging from anywhere between 150 kilowatt charging all the way to 600 kilowatt charging. So we're talking about either charging stations at the end of routes, and then the bus is able to do it, or really when we get into something like 600 kilowatt charging, we can have multiple spots along the route as well. So it really enables the uptake of e-mobility. Now, last but not least, I would like to share with you where we're heading in terms of the energy management side of things, because this is extremely important. Again, one of the myths that we'd like to bust is, or at least the challenges, let's say, is one of those things that, okay, we have a city in front of us. It's not always easy to upgrade the electrical infrastructure. That's a given, right? We have limitations on capacity. Maybe our transformer, maybe our lines are already being stressed quite a bit. We have higher density of population. There's more requirements of things like energy with air conditioning, additional things as well. So how do we solve that problem? Because at the same time, we want to introduce more and more vehicles. We want to increase the electrified fleets. We have commercial fleets getting into operation where transport companies, logistics companies are also looking at electrifying for being able to have better cost of efficiency in the total cost of ownership in the operation model. So how do we handle all this? And this is where we get into our energy management as well, which is really one of the trends and values that we're able to offer going forward. So here we have our energy management for e-mobility. Now, what this is really based on, I don't know if you can, I have this, just trying to remove this overlay, but okay, there we go. Okay, so the energy management solution, the first level is really being able to say, okay, what is our grid level and what is the capacity that we really need to cater for here as well? So for example, without getting into too many technical details, we can see here that we might have a grid capacity of 500 amps. We have, for example, 3 EV chargers. And how do we exactly manage the loads between the two? We don't want to exceed the certain capacity such that the building will run out of load or there will be trips or something like that. So what we essentially do is we provide some load management capabilities. There's some smart digital offerings that we have that are able to really direct the energy to each charging station based on what's available and based on the requirements of the vehicle. So if I just continue the graphic, you can see that based on the percentage, they change accordingly. Now the next level is very interesting. This is where we start getting into a scenario where we're looking at an adaptive model and being able to really think about how this is managed from a holistic point of view. Right? So we have, for example, in this particular graphic, we have some solar generation on the top. We have here on the bottom left some energy storage, right? So this will constantly be charging up with the energy from the solar side, renewables, or whether it's coming in from the grid, and it'll be discharging based on what the requirements are for the charging needs as well. So here we provide a software solution where we integrate everything together. And this is really being able to manage all of this together. What is your generation? What is your demand? And how to actually combine everything together. And we use some smart calculations and algorithms to be able to do this. And obviously, it's specified by the operator as well, whether you want to prioritize, for example, VIP charging stations to provide your highest level of power, whether you're able to load shed some other things, whether you need to charge your battery up accordingly. And this is really something that is relevant for being able to meet the grid requirements and energy requirements of cities today. Okay, and if you can see, all vehicles are charged at 100% eventually. That's the key goal. Now, the third level is where it becomes even more encompassing. So I talked about a holistic solution, the one before, but here in this scenario, we really factor in some big data and looking at things from a larger perspective. So in this case, it's a depot for a bus charging system, where not only do we have a larger battery, we have similar solar generation on the top, But now we are really looking at, through our cloud platform of ABB Ability, trying to get in some input data to be able to look into things like weather conditions, spot pricing for electricity, fleet schedules, how much energy do you need for a particular bus, how much time do you have to be able to charge that bus, when does it need to leave. These kind of inputs really come into the big array of what it is and look at a complete schedule. Now, obviously, this is not just for buses, but also for commercial fleets and in general management on the load side of things to be able to synchronize and make sure that we do not get out of the conditions and the electricity grid requirements. So essentially, providing this kind of solution for operators and installers, we really look into a scenario where there's savings on initial requirements. You can have a much lower grid connection, right? And a lot of our connections here in this region are based on the peak requirements that you need from the grid, and also a lower operational cost as well, because you're really able to find the most efficiencies in terms of when is the lowest or the best time to be able to charge and deliver energy to the vehicles according to what's required. And again, this is technology that we're really deploying today. Okay, so that's in a nutshell. Quite a few topics there, but I pass it over back to you, Michael, and I'm happy for Q&As a little bit later in the session.
Thank you very much, Kamal, and a very nice scenario-based presentation covering a lot of different aspects in regards to electrical vehicles and charging and grid management and energy management overall. So I'm sure you will have a lot of questions coming up later in the Q&A session. I can see they are already popping in. So now we move forward to Anna Paris from C40 Cities, who will make a presentation with focus on sustainable mobility developments in cities. So the floor is yours, Anna.
Thank you. So I'm just having some issues sharing my screen. Give me 1 second. Are you able to see my slides?
Yes.
Perfect. Okay, well, firstly, thank you very much for giving me the opportunity to speak today, particularly on World EV Day. It's going to be a tough act to follow after Kamal's presentation. I've never seen one as interactive as that, so I'll do my best to follow. So just a quick introduction. My name is Anna Paris, and I am the network manager for an organization called C40 Cities. And over the next 15 minutes, I'll be talking through the power of cities and the role that they can play in promoting electric mobility, particularly with a focus in the Asia Pacific region. So first, just to give some background on C40 Cities in case it's any organization for some of our participants today. So we are an organization that works with mayors to support each other in delivering climate action and regulation. And we unite by bringing them together to tackle climate change and sort of of these cities, around 25% of the GDP and around 700 million people worldwide. And we work with these cities to develop actions that are compatible with the Paris Agreement with the aim of making the total emissions 3 years in total to emission 40% by 2030. So then looking at these, what is the value that they can bring in e-mobility, why and how they can accelerate the electric vehicle market. So we work with these cities for a variety amount of reasons, particularly in the e-mobility space. So firstly, cities have a lot of power when it comes to implementing innovative policies and actions. So these policies that can directly influence local environment, take into account these local barriers and monitoring programs to specific population needs, and help find sort of quicker solutions to the EV puzzle, something that can be more challenging on local level when implementing policies for EV adoption. But despite being at a municipal level, they still sort of had large-scale impact on the wider EV market, particularly as we have the world population living in urban areas. Sort of a key example for this, as we all know, with the electric adoption perspective, is lack of a sufficient charging network. And in 2017, we had San Francisco implement a policy that future-proofed ensuring that every parking space had access to charging infrastructure and could be provided access to charging infrastructure. And this was done through an update in their building codes that required all parking spaces in new commercial and residential buildings to be EV ready, and the parking spaces to be sort of turnkey ready. So they already have the wiring, the capacity, the outlets, and the panel capacity installed, and also allow for future updates, which looks at the upgrading to DC fast charging. So that's a major area we're looking at development, and how can we provide charging infrastructure in all the buildings that sort of the city is planning to develop. But then sort of looking at this power and how it's taken to a larger impact globally. In this way, we've seen cities sort of collectively promote electric vehicle adoption by setting electric vehicle and electric vehicle goals, so that the signal to the industry the end of the ICE era is here, and that there is a need to shift to zero emission vehicles now. So with this mobility work, we have recognized sort of the opportunity to collectively take action and to signal to the market as a way to transform zero emission mobility within cities across the world. And a key example of this is that we have our C40 Green and Healthy Streets Declaration. So this 35 mayors are committed in 2017 to two, one of them around implementing a zero emission area in a major area of the city by 2030, and the second to procure zero emission buses from 2025. And the just cities alone, both being this collective action where 165 million people will benefit from 120,000 zero emission buses in operation, and seeing the shifting of all mobility to zero emissions within their zero emission areas. So these are the largest cities within the world signing on to mayors, signaling that the industry needs to shift to zero emissions if they want in this 2030. I think a key and most recent example of this is looking at the announcement that Uber made yesterday. They transitioned by fleet, particularly I think it was US, Europe, and particularly other regions to zero emission by. And then finally, looking at the of why we find cities a vital player within the e-mobility space is that they have the ability to demonstrate the success on the ground with electric vehicles. The national government, other cities allow the success to be shared and scaled up from a bottom-up perspective. And we're seeing this with years. We're seeing this with cities starting municipal fleets, operating and piloting smart charging way to tackle the big question around electric riding. And a key example of this is looking at London. Have their iconic where there are around 1,000 operating in the city and have quite a time, but the air quality problem with some taxis producing 30 times more NOx emissions than personal passenger vehicles. And as a response to this, as part of sort of the mayor's environmental strategy, they introduced sort of emission standards, transition their fleet to zero emission from 2018. As a response to this action, you have a company, the low emission vehicle company LEVC, have invested in mass production of an electric alternative to the London black cabs, which initially you've seen them operate on a large scale around London, then throughout the UK, and now you're seeing these vehicles operate in the Netherlands and down. And now, at the start of this year, that they're planning to release their zero emission vehicle in. So through this, we can see that the cities do have a lot of mobility market and the opportunities they present. And this we are starting to see within the Asia Pacific region and at the city level. So I just wanted to highlight a few key examples that we've come across through our work with So tackling e-mobility from the different perspectives. So we've seen in Seoul, so they're focusing on electric taxi fleets and adding subsidies for 700 electric taxis. We then have Jakarta, that has the largest BRT in the world, looking to electrify their entire bus fleet by 2030. Then, as I mentioned, you have some vehicles that are more complex to electric emergency services. But then just recently, you've seen Tokyo introduce its first electric ambulance partnership. Delhi released its electric vehicle strategy last month, outlining its sort of plans to waive registration fees and road tax and provide subsidies for new vehicles within the capital. And then the new start of August is that Seoul is planning to ban diesel vehicles from their public sector and local transport fleets over the next 5 years, with the aim to be replaced by zero-emission vehicles. At C40, we've been working quite closely with these cities to promote zero-emission vehicles and their programs through various mechanisms. One opportunity is providing technical assistance, so in-depth support, providing research for the benefits of electric vehicles, so cities can use it to communicate to their population, but also in stakeholder engagement. And then also not forgetting our core model, which is where we take each other to just demonstrate electric vehicle leadership. So just to talk a little bit more about these, to give you an idea of how we support cities. So I mentioned the aspect is that we're helping cities in technical assistance. So this is sort of long-term support to cities around specific projects. So we headed the C40 City Finance Facility in February 2020. And as I mentioned, Jakarta had, a very big ambition to tackle sort of their quite highly prioritized air quality issue, to 100% of the Jakarta bus fleet by 2030. And Jakarta being a signatory of the Green and Healthy Streets Declaration that earlier, how to buy the City Finance Facility, so the CFF, to take this technical assistance to understand the best way for them to deploy their first 100 electric. So by and producing reports that look what are the technology options with charging infrastructure, what are the different business models that they can look at, and what are the benefits of how they can deploy their electric buses. And also working, the CFSs will be also working with within Jakarta to help build capacity for the future projects that the first 100 buses are deployed, and also ensuring that the lessons that are learned in Jakarta are not just staying in Jakarta, but are reached by and building capacity and knowledge of these cities. So that's an example of sort of the technical assistance project we'd offer. And the cities that have been very promoting the benefits of electric vehicles. So whilst from a mobility perspective, I'm sure we all understand the benefits that electric vehicles bring to invest in them, but there are stakeholders, particularly from the city perspective, that need convincing. So C40 has developed an air quality benefit tool that helps to analyze environmental, economic, and health impacts from individual electric vehicle policies. And specifically, we have been working quite closely with Indian cities to understand the benefits of electrifying their bus deployment. And I will hear about Bengaluru, in understanding the benefits of deploying a policy that looked at 13,500 electric buses by 2030. And there we've seen that we can prevent 1,000 a year, have savings around 10 billion Indian rupees, and healthcare cost savings of 65 million Indian rupees. And then, as I mentioned last, the core model in C40, I think Kamal mentioned this in his presentation, that you have some cities, some regions within e-mobility, so particularly within Europe and other key nations that are quite far ahead in terms of some aspects of electric mobility, but this isn't something negative. It's something that gives others learning about electric mobility and want to implement this within their cities to understand what other cities have faced ahead of their challenges and leapfrog over these ways that other cities are faced to accelerate their adoption. And one way that we've done this is through China being quite within the electric vehicle landscape, and a lot of opportunities to present the work that China's been doing, and in the US, America, and elsewhere, to demonstrate that the cities that are currently working on sort of pilot scale models with only like 10 to 20 vehicles on the ground, that future electromobility success and large scale deployment of electric vehicles, and being able to go back and use that as a communication tool is a useful tool to have. So that's sort of the summary of my presentation and why we find cities very important within this space. And I believe we're taking questions after the Q&A. Thank you.
Thank you very much, Anna, and thank you for the introduction to the importance of the cities to accelerate the development of sustainable mobility in cities. Also interesting to see your program there, where the cities not only can get help to move forward, but also to share their experiences, and as you showed there, the good successes in many cities. And I think it's also interesting to see that what we're looking at here in terms of their action plans and the goals that are there, that we are not talking many decades ahead. It's actually within a few years that we're expecting things to move very much forward in the sector of electrical vehicles. So thank you very much for that. We are moving forward to the last presentation, which is Leah Ronalder from REN21, who will make a presentation on how to link electrical vehicles to renewable energy. So the floor is yours, Leah.
Thank you very much for that kind introduction, and also thank you for the opportunity to be here. Let me also share my screen. I hope you can see my screen all right. Yes, great. I see some nodding. Always good to get the reassurance on that. So good morning, everybody from Paris. I'm a research director at REN21, coordinating the cities work, and specifically, as Michael said, I'm here today to speak about this link between renewable energy and electric vehicles. Maybe as a quick note for those of you who do not know REN21, we are a renewable energy policy network, a global community bringing together stakeholders from science, academia, NGOs, governments, international organizations and industry. We have plenty of publications where hundreds of people are getting involved, and I'll speak a bit about that in the end as well. So our publications are probably the most comprehensive crowdsourced reports in the world, and I'm going to share some of that knowledge that we have accumulated on electric vehicles with you here today. So first of all, let me speak about this. Where do we stand when it comes to electric vehicles in cities? Actually, until recently, electricity use in urban transport was mainly for light rails, so for trams or for metros and urban trains. And the sector has only, I'm saying recently, it's not a very recent development, but has now opened up entirely to electrification, fully electric passenger cars, electric buses, and of course also the use of electric 2- and 3-wheelers that have now become quite commonplace in cities around the world. And I think Peter already mentioned this number behind is the stock of electric cars has increased significantly over the years, reaching now 7.2 million in 2019. That's a 2 million electric car increase to the year before, so 40% increase. That's quite very impressive. But also to say, in the bigger picture of things, this electric cars only comprise approximately 0.6% of the global car stock. So there's still a way to go. And why is this important for cities? I mean, these are global numbers, so of course not everything related to cities. But there was a recent study done that as of late 2018, all 40% of all electric vehicles were just allocated in 20 cities. So the role of cities and electric cars is definitely a very strong one. And the other big thing, development has of course been but the growth in the rest of the world has been also impressive. So, you know, it always seems like the rest of the world is dwarfed in comparison to what's happening in China, but the growth numbers have actually been over 50% in the last couple of years, of course, starting from a quite low base, admittedly. And here the role of municipal government is very strong. Municipal governments have taken action in procuring electric buses. For example, New York has just recently procured 500 electric buses. Santiago has procured 200 electric buses, and there are many more examples around the world. And of course, to charge these, all of these electric vehicles, we need charging infrastructure, and that is also expanding significantly. In 2019, there were more than 2 million new charging points added. Now there's over 7.5 million charging points around the world. So, okay, well, all of these developments are really impressive. We talk about these trends and developments in EVs, but I want to raise that question: where does the energy actually come? So it's great that we have electric buses and we have a rise in electric cars, but we also need to discuss that question of where does the electricity come from? Is it really that environmentally friendly? And is it really automatically clean and green if we put electric buses on the roads? Just as an example, as a little anecdote, I was at a conference and there was a mayor saying, we are now putting 200 electric buses on the road and green. We are going completely electric, right? Forgot to mention that this is completely powered by coal. So the question is always a bit, where does the electricity come from that is powering our electric vehicles? And why does this even matter? Because we keep hearing about the record installations of renewables, but if we are breaking it down, it very much comes down to the power sector, which of course is significant if we speak about linking renewable electricity with electric vehicles. But if we take a bit of a deeper look at the transport sector, as I mentioned beforehand, it's still very much dominated by fossil fuels. Just over a bit of 3% is currently coming from renewable energy, and renewable electricity is contributing until now a very tiny share to this, so only 0.3%. And non-renewable electricity, just for in case you're curious, in that big gray box, account for approximately 0.8%. In final energy demand in transport. So one of the reasons why this is the case is that the power sector does continue to receive most policy attention. We see most targets, we see most regulatory policies in the power sector, with really the transport and the heating and cooling sector lagging behind. And also, if we look at it at a global level, there are very few developments in the last years where targets or policies have been added. Of course, EVs can play an important role in advancing also renewable electricity when electric vehicles are powered by renewables. I want to say the policy support for EVs can either be directly or indirectly linked to renewables. Indirectly means a country or a city has a EV policy to support the uptake of EVs, and in parallel, but not related, also as a renewable electricity target. But there are also some examples where national or city level governments have a direct link between electric vehicles and renewable electricity. So that means if they directly support renewables by requiring electric vehicles to be charged with renewable electricity. So this is, of course, a map showing national renewable energy targets, and then also some subnational targets and EV. So we see that there are some countries that have this indirect support, but at the national level, there's currently actually only one country that has a direct support for electric vehicles to be charged with renewable electricity, and that one country is Austria. So not very promising on the global scale of things, but hoping that there will be more countries taking action. And if we look at the city level, the picture is actually quite similar. There are some cities, now we're speaking really only about targets. There are several cities that have e-mobility targets, and some of these cities also have independent renewable energy or renewable electricity targets, but there's only very few cities that are directly linking the uptake of e-mobility with also the uptake of renewable electricity. And these are, I believe, Paris, Copenhagen, and Honolulu. So some interesting examples here. If we look, of course, there are some existing examples, so not speaking about targets, but speaking about specific projects where we see a specific link between renewable electricity and electric vehicles. We see, for example, some charging stations, some municipal governments taking the lead in making sure that charging stations are directly powered by renewables. For example, in Austin, in Rabat, and in Utrecht, we have charging stations that rely completely on renewable power. We have the example of Melbourne that connected a 128 megawatt solar PV plant to its grid specifically to power its city tram. And in Santiago, a similar example where there was a 100 megawatt solar PV plant installed to supply approximately half of the electricity demand of the underground metro. And also Portland in the US has announced that its entire electric bus fleet will be powered by wind energy. So as a second, so these are of course some examples that where there's a direct mandate to link these two things. But then one indirect way that cities have taken action is also looking at vehicle bans. We are seeing increasingly more and more low emission zones, and also cities that are taking action and planning specific types of vehicles. This, of course, does not mean automatically support for EVs, but usually EVs are exempt from these bans. So it is an indirect way of how cities are incentivizing more electric vehicles on their streets. So before I'm wrapping up, I'd like to take a look at what is needed to advance renewables in transport. I think as some of the other panelists have already mentioned, it's really important that actions are taking in parallel. We need policies to actively support renewables, have ambitious targets globally across regions, countries, and sectors. We need to have policies that directly link EVs and renewable electricity. We also need to create accessible market conditions and make sure, specifically when we talk about cities, that we also align the regional, national, and subnational policies and support cities in their actions, to procure electric buses and to procure also renewable electricity. And I think there's always one thing that we tend to forget in this discussion is it's great if we scale up public transport, but we can also promote walking and cycling. And I think cities are taking a massive lead here in really making sure that they provide livable urban environments. Then another, so to say, elephant in the room is we need to also accelerate the phase out of fossil fuels and scale up the investment in renewables. There are still an impressive amount of fossil fuel subsidies in the system, more than 400 billion last year. So we need to remove these fossil fuel subsidies, divest from fossil fuels, and really accelerate the investment in renewable power and strengthen these policies for renewables in transport in general. And this change, of course, cannot happen just at that level. We need to integrate planning in all sectors. And we also need to think about how to reskill workers so that they can take on jobs highly skilled, well-paying jobs in the renewable energy industry, so to say. So just to say, as a sum up, is really this problem of the making sure that renewable energy comes in all end-use sectors. It does need a systematic solution and a systematic approach. Only putting electric vehicles is not going to solve the problem if we don't think about where the energy comes from. And maybe as a we tend to think of renewables in general as a solution for climate change, but I really want to say that it is a much more than that. Renewables can support cities in providing clean air and a healthy environment. They can provide economic opportunities, local economic opportunities for cities, provide local good-paying jobs. It is the energy transition needs local jobs, specifically also in all energy sectors. It can support affordable and inclusive energy, energy access, and of course also the energy security overall. And since I said that REN 21 has data from lots of countries around the world, this is just a shout out. We are currently producing the second edition of the Renewables in Cities Global Status Report, and that of course draws on a wide variety of experts. So we are looking for great case studies, any knowledge that you might have on trends and developments. We very much value input from people around the world. So feel free to get in touch and have your data included in the report. So thank you very much, and I'll hand it back and I'll look forward to questions.
Thank you very much, Leah, for putting some light on the energy supply as well to the transport sector and even the electrified transport sector, and the parallel actions needed in order to achieve a sustainable transformation towards electrical vehicles, and not only in terms of actions such as policies or energy efficiency measures and so on, but also parallel actions from different levels of authorities, state level and local level, cross-sectoral, and so on and so on. So obviously there is a lot of coordination to do, and in order to have a systemic approach. I think also we got some recap on many of the things that has been said during the previous presentations, or more like confirmations. So I think that was really, really great to see that kind of wrap up as well. So with that, I would like to move on to the Q&A session, where I will ask Carrie Shen from ABB to take the lead of the Q&A session.
Thank you, Michael. Thank you for the presentations by the panel of speakers. We do have a lot of questions that's coming in. So if you have any more questions, feel free to just type in your questions at the Q&A box. Okay, so Peter, we do have a few questions coming your way. Can you give us an example on vehicle-to-grid solutions?
Yes, yeah, I saw one example is actually that I found, I read about is actually in London, so it's not in Asia Pacific, but I think it was both Anna and Leah talked about that they invested in 500 electric buses there in London, and they're building a garage for 100 buses that will have the possibility to send electricity back to the grid as a way of balancing the grid. So those 100 buses can supply the grid with 1 megawatt of electricity when they're, of course, when they are available. So that's an interesting example. And another interesting example is actually, I think, is Nissan. They have introduced a parking lot where, let's say you drive to that parking lot if it's your work or whatever, and then you plug in your electric car, and then to pay for that parking is basically you pay for that parking with electricity from your car. So that's also, I think, is an interesting example on vehicle to grid. And just to expand a little bit about that as well, is the concern that that well, everyone knows that when you charge your phone or the batteries, after a while, they get bad. So what happens to batteries if you would use a service like this often? And according to the research, it seems to be that the most important thing for the battery in this case is if you keep it to a charge of 70 to 80%, the battery doesn't become bad that easily, even when you charge and discharge a little bit more to using BLQ to create services.
Okay. Thank you, Peter. There's one more question that's coming your way, so I'm just going to mention it right now. You mentioned about the major trends and developments in the energy sector. What do you foresee as the main development in 2021 next year? Having said that, we have the COVID situation going on.
Well, I think it's obvious to see. I mean, one obvious example is, of course, the reason maybe why we are sitting here today in front of our computers because of COVID. I think that the digitalization development is really going to take a leap forward after COVID here. So, I mean, these days, not only we meet online, but we shop online and we do many things, online. And there will be more also services, energy services coming. For example, the demand side response, utilizing smart meters. So that enables you to save energy, but also provide a service to the utility. Maybe by peak load, you get a message to turn off your washing machine or your TV or whatever. Or when you're going to start your TV in the evening to watch a favorite program, you get a warning that it's a peak demand, so they will cost you a little bit more. So maybe you better to record or something like that. So these kind of services will come, and just looking back, it feels like the same shift as when the first smartphone came online. We couldn't imagine what will happen. So I think it's the same. Have the same feeling now with other digitalization products and solutions coming now, and electrical vehicles for sure is going to be, I think, in a decade is going to be very common for many of us.
Okay. We do have this very interesting question that just came in, and I think it's open to the floor. The question is, EV is very good at reducing emissions, but producing EV has embedded carbon and battery waste issues. Is it still an overall good movement?
Okay, maybe I can give a response to that. I think that the one way of looking at it is that okay, yes, it costs energy to produce batteries, it costs metals and resources. So I mean, there are a lot of research being done at the moment, but when you talk of manufacturing, the manufacturing process, you have the ability to connect the factory with renewable energy. So the energy used to produce the batteries or the cars can be utilized renewable energy. When it comes to other resources, valuable metals, and for example, that is needed in batteries, recycling will become very important, and that is coming as well. So I think it's not going to be a main issue in the next maybe in the next decade. So yeah, that's my response. Maybe someone else has another answer.
I can.
Yeah, sure. If I may barge in as well.
Go ahead, Leah.
Sorry, somebody else trying to. Yeah, okay. I think here we always also need to ask ourselves the question: do we really want to replace all current fossil fuel cars with electric cars? Because is that really the objective? because if we sit, an electric traffic jam is still a traffic jam. So that's, I think it's a bit of a broader question of, is that really the goal that we want to go to? So, of course, always my message of, yes, it's not really green if it is not powered by renewables, but also taking the bit more holistic approach and saying replace every single car and every single bus with an electric version, because then our roads will be as full as they currently are. So I think there needs to be a different systematic rethinking. That means also integrating electric vehicles into wider urban planning and into improving the walkability, cyclability of cities, expanding public transport, and really having a holistic approach also on mobility and how we think mobility. And I'll pass on to whoever else wanted to also add to that discussion.
Thank you, Leah.
Yeah, I was just going to add that, look, there's actually been recent studies as well to show that battery electric vehicles fully now are actually, even the production of them, even far less CO2 emissions than initially thought as well. So a study done by, I think it's the University of Cambridge, also showed that about 95% in the world right now in the regions, it's more efficient to use an electric vehicle than an internal combustion engine throughout the lifetime of the vehicle. The only exceptions are in countries where, I think Leah mentioned it earlier, where essentially they have a huge or let's say their source of energy is mostly fossil fuels, and that's where the challenge is. And in terms of batteries, we're already looking at technology where we can repurpose electric vehicles at the end of the life, maybe after 7 to 9, 10 years, and use those into energy storage for residential use and things like that. So plenty of along the full value cycle.
That's great. Thank you, Kamal.
I just also want to add on as well,
yeah,
if that's possible.
Yeah, sure.
So within C40, we're all saying the same as what Kamal was mentioning about we're seeing emission saving. A lot of reports coming out which show emission savings still from electric vehicles versus using a conventional vehicle, even when there is sort of a high amount of fossil fuels present within the grid. I think one thing I would just want to throw out there for people to think about is that with electric vehicles and the production, there's still a lot of opportunity to make it greener, to reduce the emissions, particularly with battery manufacturing, and also with the new opportunities with battery recycling and second use. With conventional vehicles, we're at a dead end. There's no way to clear this up anymore. So if that's the reason to not go forward with electric vehicles, it's not, in our case, a very strong argument. It's only going to get greener, so to say.
Okay, thank you, everyone. That's very, very good. Back to you, Peter. There's another question that's with regards to the grid. We have a question. What will be the impact of EV charging on the grid?
Yeah, I think I cannot go into maybe, it depends on the different city or the different area where you charge your car, basically. But we have to realize that if you're looking at that graph that I showed with the electricity car stock, is less than 1% of all the cars in the world are electrical vehicles. So what will happen when we have 1% electrical vehicles? And most of the cars are. We drive our cars to work, and we park them at work, and then we drive home and we park them at home. There will be a lot of charging at nighttime, so it's really important to make sure that the grids are adapted to that. And in the long term, you can adapt the grid to that. Short term, I think you need to focus on to really see how you can maximize the efficiency of the charging, so you don't overload on the grids until they are built and adapted to the situation. So it's a general answer, but that's what I can say at the moment.
Okay, good. Thank you, Peter. We do have a few more general questions, but let me just go to Kumail, because I do have a list of questions that's directed to Kumail. So I'll just ask some of the key questions that he said. What will be the impact of EV charging on power systems network? Kumel?
Yeah, I think in general, like I covered it a little bit briefly in terms of there is definitely going to be an additional load on the power systems network. However, if you have a look at the specific country, it really depends on what's going on. So if you look at a case like New Zealand, okay, a little bit different to the typical ASEAN countries, but in New Zealand, for example, you have sufficient power generation consented for renewable energy that can cater for if the whole New Zealand fleet of vehicles will be electrified. So that power available is already sufficient. And then when we look at the constraint on the utilities and things like that, then we really need to look at these advanced digital technologies where we can really look at load managing. And this also comes down to residential side of things where Peter mentioned as well, where you look at things like time of use or the best efficient time to be able to charge your vehicles. So there will be a strain. It will be temporarily, but right now we're very early on in the stage of 1 to 2% of uptake. When we start getting to a little bit more, then we will evolve constantly for that as well.
Okay, thank you, Kumel. What do you foresee the mainstream capacity of DC fast charging for the next 5 to 10 years? You know, do you think that the capacity will increase without limit, or there's actually a physical limit that will hold back the increasing of capacity?
Capacity. Okay, so I assume they're talking about power levels and the capability to charge. So personally speaking, I think there will be some kind of, let's say, a natural type of limit. Already when we talk about our high power charging, like I mentioned, we're looking at within 5 minutes, you get about 200 kilometers worth of range if you have the right vehicle. So I think already that's starting to get to a region where people are comfortable with that fast charging capabilities. I don't think for vehicles like that we'll get to 2, 3, 4, 5 times the magnitude of that. However, if you told me that we were charging at 350 kilowatts, 5 years ago, I would have laughed at you. I myself wouldn't have realized. So that is changing. So I think there will be a hard limit, but I think it comes down to practical use cases as well. And in most cases, you can charge overnight, so it's not about speed or power or how fast you can charge. But then I think the disclaimer is also the application as well. So when we start looking at things like bus charging, we're looking at truck charging, industrial charging, we're talking about boats, we're talking about planes, then I think we'll start getting to higher and higher capacities. We're talking about 1 megawatt, 2 megawatt charging, but then they will have dedicated charging sites built for them. So it really depends on the application as well.
Okay, good. Thank you, Kumel. There's another question. Can you share your prediction of the EV charging standard wall? CCS, GB, CHAdeMO, Tesla, so do you have some sort of prediction?
Can I avoid this question? No. Look, in general, this is one of the trickiest questions to answer in this industry because, it's the same debate we have across the technology. We have, iPhones, we have Android. Will we always come into some type of USB type of connector that's consistent across everything? So yes, in general, I believe we will cater to multi-standards. So for example, China has their own standard, Tesla has their own standard. But there is a trend that we do see when we start getting into higher levels of charging. For example, we have the CCS combined charging system, which if you have a look at the vehicles that are coming out to market, and the car OEMs themselves are a good gauge to kind of see what they're doing and they adjust accordingly. We use that technology across bus charging as well, and it's definitely known to be a little bit more of the, let's call it the international type of standard. So there are trends, but I do believe it's going to be one of those things that we will have these multiple standards respective to the different countries as well for quite some time. And all the more reason to have chargers which are multi-standard, right? I'm not talking about chargers that have something like 10 different options that will confuse everything. But a typical charger that you saw in one of my pictures, for example, where it has something like 3 outlets. And then that's really a use case, and then you'll be able to charge accordingly. But we try to make it as simple as possible for the users. This is something that's a very, let's say, a debate in the industry that's quite often had.
It's true. Thank you, Kumel. I think we do have a lot of callers who are from India and Indonesia. So I think they were asking, what do you think are the main challenges for the EV market in India and Indonesia?
Okay, that's a good question, actually, because I think there's quite a few. But I think there's a stepwise improvement that can be done. So it was already mentioned earlier that people the city of Delhi has already incentivized or making plans for how they want to electrify. Indonesia, I believe, PLN came out with an article just on Friday saying what their expectations are, something like more than 300,000 electric vehicles they're expecting by the mid-2020s. So there's definitely an ambition, there's definitely a plan to incorporate electric vehicles within their countries. I think the key challenge there will be stability of the grid and energy management. So this is where solutions become really important. If you look at a country like Indonesia, it's very dispersed, right? There's islands all over the place. There's not enough energy. In some cases, they're using fossil fuels. So how do we really balance that with renewable energy, providing the technology, the load management? I think this will be the key, right? We're not looking at buying a charger, placing a charger, and then your problems are solved. No, we really need to look at a turnkey solution. So I think it's really important for countries like India and Indonesia, especially.
Okay, good. Thank you. So I think there's another question here that I think is open for everybody. Okay, so this question coming from Rama. What is an effective business model for electric buses? And how can private sector be incentivized? So I think this is pretty much quite open to the floor and see which speakers who want to take out this question. Anyone?
Sure, I can take a first shot at that question. I mean, look, the investment side of electric buses, I mean, that's still a major bottleneck, I would say, for many cities and for many entities that are implementing. Going to electric vehicles is the upfront cost. I mean, there are a lot of a variety of interesting models of how this is being financed. I mean, we see development banks providing more and more financing to that, national governments, but also city governments are repairing buses. One interesting model that I've came across recently is actually leasing. Not super commonplace yet, but I think leasing of electric buses will be, we will see one more also in the market.
Okay, thank you, Leah. Anyone else?
Yeah, I can share a little bit more on that, perhaps. I think just to add to that as well, so one example we see out of China, where obviously we talk about the plethora, the really high number of electric buses there, they've done a brilliant job. I've actually seen from one of the operators there who've incorporated, I think, 95% of their fleet into electric buses. We asked them directly and they turned around and said, look, we only had to pay 30% of the cost of the bus because it was subsidized by the government. And I think that's key here. Yes, when we look at buses, the size of the batteries in terms of what it is, the infrastructure cost, it's a little bit more different, and that will take some really good incentivizing. The cities really need to want to do it and provide those incentives. I think one of the models going forward is, I think it was Leah that you mentioned, there's a lot of subsidies still happening on the fossil fuels. So personal opinion here is, look, just redirect some of that in terms of your fleet electrification on buses, and that will by far cover a lot of the subsidies and make it easier for operators to get into that model. So the governments, the private ownerships, they really need to think about these lines. If you're looking at a pure cost of bus versus cost of electric bus versus cost of diesel bus, it's not going to work. So you really need a full approach on that front.
Thank you. Thank you, Kumar and Leah. Okay. I think due to the time constraint, we do have time for one last question, okay? So I'll just ask this question. In terms of power system stability, how will you deal with bulk electricity required to charge batteries at bus terminal in several locations, which could happen simultaneously or in different times?
Does anyone else want to take that question? No? Okay. Yes, so look, I think it comes back down to the holistic thing. So when we look at the key scenario of what we looked at of a bus depot, let's not look at just the bus depot as the complete system. So your question really looks at the whole city, and this is really important. So let's assess, let's model what is the city requirements, what is the generation required there, and then we can cater accordingly, right? It's easy enough to be able to see what are the requirements, and we start looking at big data, we're able to really identify what is the information and what is the charging that we can do from there. So a lot of the presenters already spoke about the initiatives that we have that cities are wanting to go to electrify. And so when you have an operator who's looking at deploying bus depots, things like this. We really look at fleet schedules and being efficient from that front. So it's a complete holistic view. It's not an easy solution. It will take some planning and synchronizing with on a government level, on an operator level. Different countries have different procurement models, whether they're looking at things like single sourcing for buses or whether they're looking at different operators look at different type of sourcing models. So yes, it's a tricky question to answer, but in general, it comes down to looking at what the grid capacity is and how to manage the load accordingly. But this is one of the key questions that we need to address going forward as well. So it's a good question.
Thank you, Kumar. Okay, so I will just ask for closing remarks. Thank you for a very good discussion here, and thank you for all the questions that's been sent in. Before I hand it over to Michael, I will just ask for the closing remarks from each of the speakers. I will start with you, Peter, first.
Okay, thank you, Carrie. Okay, yeah, so thank you very much for this great session, and I think all the presentations were very interesting. We get 4 different perspectives that I think is important to have when it comes to electrical vehicles. But I want my kind of message here is to look from a city perspective and how do cities, local governments, and countries invest in the most efficient, optimized energy infrastructure so you can manage the energy transition and the growth of electrical vehicles. And I mean, because there are other energy demands that are growing as well. And looking into the southern part of the world, the cooling demand is really growing a lot. And looking at China and India, Indonesia, it's going to be a boom when it comes to the growth of cooling demands. When people can start to afford to have air conditioning, people will buy it. That will consume electricity, and they will buy electric car later as well. So you really have to address the energy demand to make the most efficient solutions and most sustainable solutions. And so that's my key message here. And I mean that will help integrate electrical vehicles. It will also integrate renewable energy as well. Thank you.
Thank you, Peter. Kumar.
Yeah, from my perspective, I think one of the things is that technology is available today, but I think the real key message is highlighted by Peter, Leah, and Anna to show that, look, this is a citywide, this is a renewable initiative, it's an all-encompassing type of thing, and that's really needed to really launch the e-mobility uptake. So work in synergy together, figure out what the needs are. It's required from people like yourselves and the organizations. Today is World EV Day, so go ahead and make your pledge that if you're not already driving, make sure that your next vehicle is electric, and yeah, just continue the momentum. Thanks.
Thank you. Anna?
Yes, I'll keep it short and sweet, not to repeat what Peter and Carl have been saying, but just to say, well, first of all, thank you for allowing me to present on World EV Day on what C40's initiative is doing. I think one key message that I just want to put out there is that sort of cities have this enormous power to transform the EV market that doesn't need to be ignored, and I can imagine with this audience it isn't being ignored, but they're ready to invest in zero emission vehicle solutions, and what they're waiting for in certain aspects is for the private sector to get their skin in the game, particularly with certain aspects within charging infrastructure and availability of EVs, particularly with things with ride hailing. So they're ready, they're willing. Now it's just about getting all these EVs on the road.
Thank you, Anna. Yeah.
I think my closing remarks are: if you have EVs, make sure you know where your power is coming from. Make sure it's renewable solutions, and put livable urban environments in the center of your actions, and think about how renewables can contribute to that. And then lastly, also as a personal note, let's remove fossil fuel subsidies and make it playing field for everybody.
Okay, thank you, Leah. Okay, back to you, Michael. Thank you.
Thank you very much. I think we have had a great session here today, and definitely a lot of myths have been busted. I think I will conclude that besides the obvious benefits of electrical vehicles by a little bit higher efficiency in general, no matter the fuel, the local pollution and so on, I would say that the convenience factors, I would say, is gone already. The negative parts of that. The technologies for infrastructure is there already. There is a lot to do, obviously, in regards to activities and promoting the sustainable development of the transition towards an electrified EV market or transport market. So yeah, I think it's been great. I would like to thank all the panelists, Sami, Carrie, Peter, Kumal, Anna, Leah. I think I got everyone there, right? For this great session, but also the audience that has been here asking great questions. Don't hesitate to reach out to us, anyone in the panel. I'm sure that even though we as organizations who have participated in this webinar, I'm sure there is a lot of great ideas and good opportunities for collaboration among the audience as well. Personally, what I will take with me is that I will definitely have an electrical vehicle for my domestic holidays in the future, and I should better go buy a bicycle also. So that's with that, I would just like to ask everyone, wish you a happy World EV Day, and thanks for today.
Thank you, everyone.
Thank you.
Thank you.
Thank you.